In our previous videos, we have shown the construction of these kind of things there. Now we will try to show you the controlling of these variables and four different symmetries. The 4 points are controlling there. I have already said that in geometrifying trigonometry, there are four configurations for same thing. LAZ is the base, that is the first configuration of cos theta, and its corresponding complement side is LEZ, that is hidden here, that is LEZ. A is cos theta, E is sin theta. Similarly, for the same diagonal, same hypotenuse, we have the mirror image of this on that side, that is the LBZ. It is also cos theta, and corresponding complement side is LFZ. In geometrifying trigonometry simulator, we use this convention. The hypotenuse is on red color, base is in blue color, and perpendicular is in green color, such that we can identify the things very easily. Pivot point is the point where hypotenuse and base are touching. Nodal, in the later videos I will show the more conventions of naming for these points, because without proper naming of the points and line segments we cannot write good theorems. Until we have conventions strong enough, we cannot write good theorems in any kind of theory. So for any kind of theory designing, the nomenclature standardization and formalization are very important part of theory designing, such that we can map every words that we use in the theory to be precisely meaningful. Everything should have a precise meaning. It has a location address. So here we can say that every of our line segment has a proper nomenclature, and L is the starting given line segment. Here it is hypotenuse, since we are dealing with the cos theta and sin theta. If we deal with tan theta, then tan theta is perpendicular by base, where denominator is the input, so base is taken as the L, which is the given line segment. If we work with say cot theta, then B by P, in that case P, the perpendicular, will be taken as the L, because the denominator is the input line segment and numerator is the output line segment, as per the theory of geometrifying trigonometry. And you will find that in classical trigonometry also, the books you are following, whatever you are doing from school days, you have not studied this in particularly with these nomenclatures, because you were solving the problems. But when you have to solve the robot arm movements, or you have to check the constraints of the bridges designing or girder designing, for architectural designing, structural engineering designing, or for jewelry designing, or in the moving parts designing for the ANSYS, or in Pro Engineer, or in SolidWorks, or even in CAD Inventor, you will find that proper nomenclature of every blocks or every kind of elements is very much necessary. Otherwise you cannot address the things when you will communicate with your team members, or with any people, or with the community of the who are dealing with the theory, or with the practical applications, or manufacturing, whoever you're concerned in the whole team. They cannot communicate properly until you have the proper nomenclature for everything. So designing the any theory, we need, while designing, we have to precisely name the things here. LAZ means it's a type of cos theta, and its alignment is of this type. Its corresponding sin theta is LEZ, which is here, that is LEZ. A and E are the complements, and inverse for A, the inverse is O, that is sec theta, a special symmetry of sec theta, which is having a unique property. We will explain it in the later videos. Now, from previous videos, we have understood how to construct these arrangements for every different symmetries. Here is one symmetry, and Here is another symmetry, here is another symmetry for the cos theta sin theta combination, here is another symmetry. So 4 symmetries are constructed for a single theta, single seed angle theta. Now suppose this is the seed angle, and for A the corresponding complement line segment is LEZ. For LBZ, that is the cos theta, again blue, which is the base. For LBZ the triangle is this one, so its corresponding complement is LFZ, which is sin theta. For B it is F. For C, LCZ, it's another symmetry configuration. For LCZ, this is the base. We find the LEZ, LEFGH, LGZ is the corresponding complement. LGZ is the corresponding complement for ABCDEFGH. Now here this is the base, so it should be ABCD, ABCD, ABCD. This should be C, LCZ, and its corresponding complement is EFGH. Its corresponding complement is G, which is LGZ. We have to write it properly. LGZ. This is the corresponding perpendicular for this triangle. And for LDZ, A, B, C, D, this one is the LDZ, so its name should come as the LDZ. Geogebra has intelligence that it don't allow the repetition of name. For the D is a cos theta, is a symmetry variety of cos theta, and corresponding perpendicular for this triangle is this one, ABCDEFGH, so it should be LHZ, and it is the sin theta variety. It is the symmetry of sin theta, LHZ. Now we have got the points there, and the line segments are found here. Corresponding naming conventions are here. This is the stretch point where the perpendicular is formed. It is written as a LA, A with E. So A and E, both lines are meeting here, so the convention is written as LE stretch point. Nodal, pivot and nodal for the first line segment is written in this simple way, pivot and nodal for cos theta sin theta combination. For tan theta sec theta cosec theta combinations, the geometry and nomenclature have the different meanings, and the convention is same, but the naming will change. I will show it in the later videos. LAE stretch, the name of this is the LBF stretch, and I should change its color so that in tracing I can see its behavior. LBF stretch, this one is with LD and LH are cutting here, so its name should be LDH, DH stretch, and it is the stretch point because stretch point defines the point where the largest triangle forms in generalized geometrifying trigonometry. But for normal trigonometry, in geometrifying trigonometry, we take it as the special purpose trigonometry, that is the classical trigonometry with the 90-degree angles. The 90 degree is the largest angle in right angle triangle. It is the stretch point. Pivot point is the acute angle. It is taken in that way, but it has a convention that it can rotate in the 360 degree and it will change its position. Now we have seen, we have to check that all these points trace are on, these points trace is also on, all have the different colors. Now here the trace is also on, here the trace is also on. Now we will see how the points of the stretch points will change, move, how those will move when the controller triangle, the controller point will animate, that is when it will change its position. We want to see the behavior of the tracing of these points such that we can understand the wave nature and the wavelet natures of our objects. For the cos theta and sin theta case, we are not doing cos square theta and sin square theta yet. In our next video, we will come with the cos square theta and sin square theta. Obviously, there are 16 types of image forms due to this animation. The locus of these points, the 16 different kind of traveling of the points, you can see that the locus will found from those movements. But those movements, sometimes some points will overlap on other point and the locus will remain same. Here you can see the locus is fixed. Even the 4 points are moving, the robot arms are moving, still though all are moving on a single locus, the direction of the movements are changing but the locus is same. We can stop the animation here. Single point controller which is changing here. If we pan it or zoom it, any whatever we do, its locus vanishes, and we cannot drag these points. We have to drag these points only. We can drag the controller point only to get the rearrangement of the positions. Because we have designed this system in this way, you will get this GeoGebra file in the location where I have placed it, and it is the link is given in the description of the video. You can automatically check, you can play with that, you can download it, you can edit it in your own way. I am keeping the whole training GeoGebra files in the single repository so that you can also edit that, play with that. You can do the experiments, you can write your own theory, you can write your own theorems also. You can find many deeper insights out of that. Even you can suggest newer naming conventions or better understanding for the naming conventions to grab more kind of deeper theories. If you want to design or develop, that is open. The theory is in the process and it is building. It is not yet completely matured because I am a mechanical engineer working for structural engineering and the robot arms, and to the extent I have seen its uses in 20 years, I have developed it in my own way. You can think it in other places also, in jewelry designs, in fashion designs, or in some other places also. Several deeper theorems you can think of. You have more insights for many purposes. And it's the ubiquitous subject because geometry and trigonometry are applied everywhere. So you have the opportunity to use it anywhere, and you can make your own conventions, and you can have newer varieties of the theorems which we have not seen anywhere ever yet, because everyone are not expert in every field. You are expert in your field and you can use the geometry and trigonometry in your field to get more insights and deeper insights, and we will also get the opportunity to learn from you. So thanks. We will proceed with the next video with newer, deeper cos square theta, sin square theta varieties. So 16 different points will come in that video. I am trying to increase 1 point at a time in different videos such that we can check the nature of the locus when the animation works. Thank you.